Welcome to the project demonstration of security based circuit breaker maintenance management system. So here the security nothing but in order to protect the devices, so instead of using the electromagnetic relays we are using the triacs directly, so which will act as a fast switching. So here the next operation is whenever the load increases in the threshold value, that will be identified by our current transformer CT. So based on that threshold set inside the microcontroller, so we are going to isolate the power supply to this bulb, means to the load, with help of BT136 triac. So here the current transformer will provide us the AC signal as of now because we have connected that current transformer in series with the load. So whenever the load increases, the current also across the CT will increases. So the current will be converted into the voltage, but that is going to be the AC voltage. So controller can't measure the AC voltage. For that purpose, we are making use of this potential divider circuit. So here we can see the 100 kilo ohm resistors, so which will divide the voltage is 100:10, because here we are getting the 230 volts around maximum of. So in order to, we need to step down the voltage using this potential divider circuit. We are going to step down the voltage up to 10 volts AC, and we need to convert that with help of this DB107, which is the IC version of full wave bridge rectifier. So after that we will get the pulsating DC of 10 volts. It's around 10 volts. Based on the current, the voltage varies. So I am talking about the maximum voltage, 10 volts. So after that, the pulsating DC also has the ripples. So in order to remove the ripples, we are making use of these two capacitors to make it as a smooth DC, and that is directly given as input to the microcontroller at A0 pin here. So here also we are using one resistor which will act as again potential divider circuit, which has of 3:1. So means if the controller getting 3 volts, so then it has to multiply it with the 3 again, because we are using the potential divider of 3:1 potential divider ratio. So there will get the 3 volts if is get the 9 volts. So that is the ratio. So here we set the limit for 90 watts if the load is above 90 watts, because for demonstration easy purpose we kept the limit of 90 watts. In real time we can go up to 2000 watts or 1000 watts. So whenever the load crosses the 90 watts, then automatically the microcontroller will display the message of heavy load, and it will on this LED indication and alert message, and the power supply to this load will be isolated by switching off this BT136 triac. So here the whole system getting power supply from this 230 volts AC, that is a parallel input to the load and to this regulated power supply board. On this board we can see the transformation, rectification, filtration and regulation. So after these 4 stages we will get the 5 volts DC output directly. Transformation will step down the 230 volts AC to 12 volts AC. Rectification to convert the AC to pulsating DC. Filtration to remove the pulses and to make that voltage into the pure DC voltage. Regulation to make that 5 volts constant DC. So we got the 5 volts DC, that is the main operating voltage from the microcontroller and to the LCD display. So once we provide that, it start reading input from the this current transformer circuitry. So it will keep on checking that if it crosses the threshold value, then automatically it will isolate the power supply to the load. So let us see demonstration. So initially, so welcome message will be displayed on the LCD screen. So we can see that. So on this motherboard, so 3 major components. One is the reset switch. So inner project, which will play the major role. So whenever the heavy load occurs, it will stays there only. If you change the load also, it won't resume the power supply, as we need to check it manually, because in electrical when the circuit breaks, then we need to check manually and we should do reset the system. And the next microcontroller, which will taking care of input and outputs, and another is a crystal oscillator. This steel plated one is a crystal oscillator, which will provide the 20 megahertz of clock frequency to the controller, so which is used to execute the instructions step by step based on the clock pulses. So now let us connect the 60 watts bulb. So if we keep on this for longer duration also, it is normal load. With load or without load, it will check whether the load is 0 volts or 60 watts. 0 watts or 60 watts. If it is below 90 watts, it's normal load. So let us connect the 100 watts bulb. So when it connects, automatically after 1 second of duration it will check. If it is heavy load, then it will switch off again. So if you connect the normal load also, it won't resume the power supply, because in electrical, as we discussed, we need to check the status. Right. So in this way we are going to protect the loads by using the triac with ultra fast switching.